Let's take a look a little more closely at this formula that we use for our interval. So we have x bar plus or minus z star times sigma over the square root of n. And specifically, I want to take a look at what changing our confidence level, so changing z star, does to the width of our interval, if it makes it narrower or wider, and then also what changing our sample size does to our interval. Okay, so we're going to use a problem, and we're just going to change the sample size to see how that affects it, and then we'll use the same problem and then just change our confidence level. So the problem we're going to look at is, we measure the heights of 40 randomly chosen men, and we get a mean height of 175 centimeters. So we're starting with x bar is equal to 175, and our n is 40. We also know the standard deviation of men's heights is 20 centimeters. So sigma is equal to 20. Okay. And in this first example, we're going to change the sample size. So we start with n is 40, we go to n is 100, and n is 400. Okay, we're going to see what happens. So I would recommend using Excel on this, so you can just kind of cycle through and get those values and plot them on the number line. And then I want you to come up with a hypothesis here. So as the sample size increases, what happens to the width of the interval? Okay, and then on number 6, you're going to change the confidence level. So same scenario, but you're going to do an 80, a 90, and a 99% confidence interval, and you're going to plot those values again and then come up with a set of hypotheses. So I think you know what's coming. You're going to pause the video and give it a try. All right, so hopefully you plugged those into Excel and you were able to plot those. I'm going to go ahead and list our sample sizes on the side. So I have n is equal to 40. And when I plugged that into our calculator, I got a range of values from 168 to 181 for my confidence interval. So that would look like from here to here. Okay, and then for the next interval, okay, I did n equals 100. And I got 171 to 178. Okay, so that looks like from here to here. Okay, so a little bit smaller interval. And then for the third one, n is 400, so quite a bit bigger. And I got 173 to 176. So I'm looking at an interval from here to here. Okay, so just about there. All right, so my conclusion here is, as my sample size n increases, the width of the interval decreases. Okay, and as the sample size decreases, the width of the interval increases. So if I wanted to really narrow down my interval, so I had a much closer idea of what that true mean might be, one way I could accomplish that would be to increase my sample size. So the bigger the sample size is, the better I would be able to narrow down what my true mean might be. So there's one of our conclusions related to changing the sample size. And then let's take a look at what happens if we change our confidence level. So let's start out with a really low confidence level, an 80% confidence level. And we are going to come back and talk about that in the next video, what that number means. Okay, so an 80% confidence level gave me a range of values from 170 to 179. Okay, so it's an 80% confidence level. So that's here to about here. Okay, and then a 90% confidence level gave me 169 to about 180. Okay, so a little bit bigger, but not too much bigger. Then I went to a 99% confidence interval, and that gave me from 166 to 183. Okay, so right about in there. So it looks like that as the confidence level increases, the width of the interval also increases. And as my confidence level decreases, the width of my interval also decreases. So if I wanted to get a closer or a narrower band on my true mean, I would have to give up some confidence, or I need to increase my sample size, okay, in order to get that interval to be smaller or narrower. So hopefully that gives you some insight into how to manipulate that width of that interval.